Welcome to another tutorial. In this one I'm going to talk about an idea called non-deterministic finite automaton. So it's basically the idea where a start point has multiple outputs that have the same label, okay? And how some programmers can be able to overlook this trick by okay, so basically the idea is a state can have more than one output, right? But that output can all have the same label. And if even if you were to tell someone, no, I don't want an output to have the same label, they can bypass your output by using an empty string, the null string. So what does a non-deterministic programming mean? It means that the ultimate path through the machine is not determined by the input alone. Therefore, we say that this machine is non-deterministic. Human choices become a factor in selecting the path. The machine does not make all its own determinations. Remember that an output can be influenced by a person. So let's just quickly step into this machine and see what I'm talking about. So I have a label that has one output, but they're all the same. They're all the same output. So if I were to step into it, I would go to the next state machine, because this state Q0 has only one output. But you can bypass that by having a state where, okay, I don't want to show that my output has one output, right? I can use the empty null string. So this causes a problem because programmers are able to bypass this statement saying that, well, I don't want my state to only have one output. So they can use, okay, they can claim to say that although my state doesn't have one output, they used a empty string, the null string, to go into the next state. But if you look closely at my state, you'll realize that, hang on, if I were to remove the null string, you'll still have only one output. So let's step into the machine and see what I'm talking about. So as you can see, if you run it, I had a single output from this one with another state output of null, but my state machine still went to the next step. So this is just my first part in explaining non-deterministic finite automatons. It's basically a collection of three things: a finite set of states with one start and some final states, an alphabet of sum of possible input letters, a finite set of transitions that describe how to proceed from each state to other states along edges labeled with letters of the alphabet but not the null string, where we allow the possibility of more than one edge with the same label from any state, and some state for which certain inputs have no edges. Okay, I know that sounds like a mouthful, but I will explain it with more examples in my next tutorials. Just stick around.